Now we'll come to a somewhat case study again, where we will discuss about this. Yesterday also I talked about this pore water pressure, how to mitigate it, and this like this closure is the final. Now also there is a guideline for the closure. Also you have to write to the ministry that you are going to make a closure. You cannot do a closure right now. And even the mine now during excavation for the coal mine also, we are preparing a perspective that in future you can go for open cast mining. This will be finally the reclaimed safe. Everything we are giving now before going for mining also. But the way, that means here what is there, how to design it. Some of the things which you are not considering needs to be considered. And when we are talking about like a final closure, the slope is almost 1:3. So that way, so when we are talking about that also, we cannot grow large trees, only small trees we are talking about, and there are different issues. Like first thing, mostly if you any top surface, which actually it was showing like plateau. That is important, its drainage is very important. So then that only we can remove the population to the landfill, reclaimed landfill. So that is what you were talking about, the slope, that you have to maintain it. And again, like they are considered snow, we don't have. So all these things have to be customized. And our standard is not that, so far Indian standard is not that well developed. But here we can take the clue from there what is the advanced countries are doing, because the number of closures in our case is very less so far. Only except Coal India, Northern Coalfield and so on, they have made some closures. You can see in the picture also how they have drawn it, how beautiful they have provided this, what I will say, gabion blocks at the end. Then they have done a good plantation, but not big trees. That is that you have to keep in mind. Yes, now I request Subhranshu. So this will be a good example, particularly for them who are in operation of these fly ash dyes. Yes.
Good afternoon, everyone. My name is Subhranshu. I am a research scholar in this organization as well as working in Tata Consulting Engineers. So this is a case study project where we have done this project long back, but I think this is the site, this is the location we can share this knowledge, whatever the learning we have done. But I am thankful to all the professors here because they have given the opportunity to speak on this, and I am not going to the detail of the design part. I will touch the operational part, construction part, how a good construction operation help to the design more stable, that I am highlighting here. So before going to the project, I am just giving you the brief history of the project. This project was started around 2000. Then there is a 3-stage earthen raising for that ash dike, and that was done in 2013. After the 3-stage raising, they have done filled that entire area with the fly ash slurries. Then again, after 4 years of operation, they have a plan for 2-stage raising, and they have raised this entire ash pond with the fly ash material with a soil cover. After that, 1 year of operation, there is seepage and subsidence on about 100-meter stretch on one side of the ash dike. And during this seepage condition and subsidence, there was no one there to observe this, how it started and how it is happened. However, luckily, some of the photographs taken by the security personnel, those moving around the ash dike, they have given the photographs for our analysis. The first sign occurred during a pre-monsoon rainfall, where you can see the minor longitudinal cracks are developed on the one of the intermediate benches. Then after some time, around 1 week or 2 weeks, they observed a sudden subsidence of the material. So this picture, I am thankful to the person who has visited that site that time. So it is giving a clear picture that how inspection is a very vital for a ash dike or wherever we are working. That inspection is a must. The inspection guy must be a background of the operation, then he can identify that one. Then they inform the owner. Then we visited the site, and if you see, I will go to the second slide. There is a water bottle in the substation zone. You can see there is around around 600 to 700 mm, more than 800 mm vertical subsidence and lateral sliding also. And at the beginning there was no seepage, but after 1 or 2 days we will observe more seepage on the subsidence zone. So now the problem came to us as to give a solution, because monsoon is coming, and how to protect this arch dike before the failure. And we stopped immediately any of the operation inside the pond. First activity, we instructed the owner to stop the activity so that there will be no additional pressure on this side. Then we then after some time we observed the rock top, which was constructed on the starter dike top, that has moved lateral direction around 500 to 600 mm, and there are lot of seepage on the downstream slope of the earthen embankment. And what to do, we don't have any idea at that time. So we started putting the sandbags on the surfaces and put some drainage path so that the water, whatever the water pressure is coming behind that rock top, that can be released. So it is the first step we have given on that side. Then we put the entire buttressing of the entire slope from the top to bottom, so that before arriving any solution, at least we have some protection there. That may not be sufficient for the, at least it will add to for the erosions. So that way we have created a counter burn on the entire slope from top to bottom, and this counter burn has helped to further sliding of the rock top and the starter dike. Then I'm explaining the problem statement, what we observed from the drawings. There are no such drawings for this site, only some past design drawings are available, no eligible drawings. That is the main problem when we are dealing with any of the arch dikes or old dikes. We don't have any drawings and the real documents. So however, we have we have collected some of the design drawings, and we figured it how the dam was constructed and where is the problem. So there is a starter dam of 10 meter height. Then there is a 3-stage raising with the earthen material. Then in 2013, after 2013, they have raised up to 2037 level, 2 arch dike raisings. And this raising was done with some additional relief well and filter sand all along the 3 raisings, and that was done in 2017. Now what happened? They have assumed that ferritic surface will move this way, and there will be no such problem in this area. But what happened actually? We observed that, and this observation is from the field data. We have done some of the piezometers there, and we have, based on the piezometric data, we have derived this ferritic surface, how the water has moved in these slopes, and this is the burn where the subsidence occur first, and we have observed a lot of seepage in the downstream side. So the operation, when we stopped the operation, we observed the seepage is continuing, but after some time the seepage has stopped little bit, and whatever the additional protection like the sand burn we have bags we have given, that additionally supported the failure. So there is no such failure in that side, only localized failures happen. Now for the client has asked for the solution. So what to do, we don't have any idea how to proceed. Then we figured out the challenges in this side. The first challenge is there is no space in the downstream side. Suppose we want to do any additional buttressing, there is no space, and there is a natural nala on the downstream side. So we cannot move to that, we cannot move for any construction on the downstream side. The second obstruction was continuous seepage, subsidence and soil erosion from the slope surface and toe. And it will may happen that in a rainy season the seepage will all continue further. Then third constraint was time of that investigation, strengthening and retrofitting. There is no time because monsoon is coming in 2 months. We have to complete whatever the things, investigation, retrofitting will be 3 months. So that is another challenge. Fourth challenge was engaging multiple agencies, because whenever there is a crunch situation, we don't have a contract to engage a third party. The client is having there is no resources available at site, and we have to give the solution as well as to have the construction activity. So how to proceed? We finalized, as per the discussion with client, that we will not go with a design approach that will give you a solution factor safety and then we'll design it. So whatever observational method we have approached 2 methods. One is observational method and the performance approach. In observation we have installed so many bore piezometric holes. From that data we have arrived some of the ferritic surface. Then the performance, how the piezometer is, the water level is dipping in the piezometers, that we have done in the performance approach. So these two approaches we have explained to client that if you go by this approach, then we can save the time, and parallelly you can design as well as parallelly you can construct the things. So it was accepted by the client that since there is a current situation, we can go with this. Then we started doing the investigation. Parallelly the construction activity is going on. I will show you how the construction will move. So these are the borehole points, and we started these boreholes all around because this is the failure zone. So we started the borehole location first here, and these boreholes are again after the boring we have converted to this standby piezometers. Then we have additionally parallelly these are the boreholes we have created all around to know is there any other zones we can find any seepage water on that piezometers. Additionally we have tried another thing. We did 3 big dewatering points, and we tried to dewater the whatever the seepage water inside, but we failed. After 1 day of dewatering, there is no water to pump out. So what we found that inside pond there is no such issue of water accumulating inside. Whatever the water is accumulating, that is on the inside the resins. So that is confirmed. So the dewatering point was there to monitor what are the water levels, but that was a failure in terms of our expectation that we are planning to evacuate the water from there. So then we proceed with a new approach. You see the 3 piezometers here we have installed on the sloping ground where the erosions happen, and this is the method we have adopted, not based on any analysis. We just put we observed there is a lot of clogging of the rock toe. So we started cleaning the rock toe at the bench, and also put one horizontal drain. We insert 1 meter pipe, then one flexible pipe, and this 1 meter pipe has perforation and geotextile surrounding that. So we observed that water is coming behind this rock toe. So we concluded from the observation that there may be the sand, whatever the filter media behind this rock toe, that is clogged. And when we put this 1 meter length horizontal pipe, now the water is coming freely to the drains. So that is the observation we have taken into our consideration, that whatever the water is coming, seepage water, that is clogged the entire rock toe on this stretch. So we will first relieve this water pressure behind. So this type of flexible pipe we have installed on this 100-meter stretch, and continuously monitoring this piezometer data. Every day, twice we are monitoring this piezometer data for the next 1 month. So these data have given the idea if the water is coming, then water level is fluctuating here. So that information we have taken into our consideration. So the performance based and that observational method, that 2 methods we have taken in this project. Then we finalized the solution with the owner how to mitigate this seepage problem. So at that time there was a Gabion contractor available in this area. So there are a lot of Gabion boxes are there, and boulders are available. So we designed this Gabion as a rock toe filter, and with some height and with lateral pressure we have designed as a gravity wall, and behind this Gabion we put the geotextile material, then graded filter materials all around, so that it will act as a big rock toe, and at the same time this Gabion will provide the support or buttressing to the existing slopes. And whatever the rock toe was there on the on the starter dike and on the fast raising, we created some finger dents beneath this rock toe and some finger dents here. I will show you how the finger dents was installed. And after this entire scheme, the entire slope profiling will be done, and that will be proposed for the entire from top to bottom. So this is the proposed solution given to client, and that time client is accepted. Okay, we can proceed, because how we have convinced the client, because we have proved that there is some water coming behind the rock toe, and this will help to release the whatever the pore pressure is coming behind. So we don't have any calculation to prove it, only based on the observation of 1 month. That is the given to client as a proof. Then we propose this type of finger dents where the perforation pipe will be there with geotextile and graded filters, and that is in a trench as well as in behind the Gabion wall. So this was the solution we have given. So parallel the investigation is going on. From the investigation data also we have finalized the design parameters for the design aspect, And this is a parallel activity. Construction is going on, simultaneously we are analyzing that thing. And this is only a limit equilibrium analysis, no much detailed analysis. So we observe that if the steady state condition has arrived with this arrangement on thing, the factor safety is nearly 1. So we have to increase the factor safety. So the first, second step, we have, suppose the steady state condition with the gabion. If you put the gabion here, and we have to channelize the whatever the water safety surface coming, we have to channelize through this gabion, then what will be the factor safety? It is still below 1.5. Then we proposed that if we reduce the water pressure by lowering the water table, then the factor safety may increase. So the ultimate goal is to address the water problem. Then parallelly, what construction activity going on? First, the cleaning of all the ductors, and it is a big task to clean the old ductor. When you move any boulders from there, water is coming. So that is a big issue where the client is afraid of that. If you put the entire section, the water may wash out the entire section. So we tried 10 meter, 100 meter, we divided in 10 sections. Every 10 meter we remove this ductor, we rebuild the ductor, and the other section is intact. So the stage of construction is stages construction. Then second point, we temporarily, everywhere we put this finger dents all around the ductor, existing ductor, so that the water will come out behind the ductor. Then placing of the gabion in segment wise, not in a full 100 meter stage, we work in segment wise here. Then the permanent finger dents and toe dents on the benches and the intermediate benches and the starter die. Then the last activity is the backfilling, compaction, and the provision of surface drainage by the tube drains. So now you see the photographs when we clean the entire area, reprofile these sections. You can see the 100 meter stretch gabion wall. Then you see how the internal subsurface drainage was diverted to the nearest nala, and whatever the surface runoff is coming, we have diverted in 3 sections. And after this section, we have put the entire plantation on the surface. We newly reprofiled sections with that newly constructed rock toe as well as the gabion wall. You can see there is also a movement in the gabion wall. When it was constructed, it was in a straight line. But after this construction of 6 months, when the monsoon has arrived, you can see there is some movement. We have monitored this movement through the survey monuments installed in this gabion wall, and it moved around 100 to 500 mm also. But there is no such movement on the top benches. Here also we have some survey monuments, and piezometer is also there. The piezometer level is varying around 600 to 700 after the monsoon also. So that is the observation point, and we keep on monitoring this entire system for next 3 years under the observation. So we find that there is no such further movement in this rock toe. Then we said after 1 year also there is water coming in the flexible pipe. Whatever the flexible pipe we have installed, you see the rock toe is repaired, the water is coming, and whatever the gabion wall is constructed, there is some misalignment, but still it is functioning well. Then periodically we inspect in every 3 months time. We have to visit the site. We have to take whatever the water is accumulating. This is a top surface, so there is no water accumulation in this stage. We kept sandbags for the throughout the year. Is there any emergency? You can have some protection there. Then there is tube drain energy distribution structures to channelize all the surface water from top to bottom. And you can see the bulging in the gabion walls. Water is coming out of the gabion walls, but you can see the bulging, and it is observed all along the 100 meter. And these are the 2 other sections where that water is coming throughout the year, and you can see there are multiple levels. Pipes are coming that the finger dents that is outletting to these children's. And the learnings, what are the learnings we have observed? The solution of slow fashion that should be looked not to locally, it should be holistically to entire area. Second learning was design analysis to be coupled with the observation and performance approach, not only the theoretical analysis. We have to observe, monitor for the next couple of years to conclude, and the continuous monitoring. That activity is client accepted that we need to follow, because that's unskilled. That inspection security person has given the idea that you should inspect every day. So next is the validation of the design during the execution. Whatever the design inputs we have given, that should be validated. And last one is the instability due to the inefficient drainage network. That drainage, whatever the surface drainage that we have done, with the site. Then the long-term risks and probable detrimental effects, that has been evaluated like the movement of the Gabion wall. We have observed the movement of the Gabion wall for next 3 years. Now, based on this presentation, I am just concluding that a good design can be a bad if your construction and monitoring is not there, and a bad design can be a good if your construction is good, and our monitoring is your monitoring that. So that is the concluding, and in our second half, sir will discuss about this monitoring and that operational and other thing. So we have not done any design execution there, but monitoring part we have done with the help of the client. So that is the main point in this presentation. Thank you.
Very good.
Yes, any question?
Sir,
Okay.
please.
No, just asking out of curiosity, the Gabion wall you constructed, right? You said there is a displacement.
Yes.
So just I'm asking, I may be wrong, that you can't we install any kind of weak holes or something? Like
Gabion is still a void, na? So the water will also percolate to the
Then
Gabion.
also there was a displacement.
Yes, there is a displacement.
It was void, right?
Void.
Oh,
Gabion boxes, Gabion is full of voids.
full of voids.
Ah.
Oh, okay. So more
And
enough
in
weak
the
holes.
backside of the Gabion we have installed the geotex tank and a filter.
Yeah.
So it is, but since the movement has happened, but there is no further movement, so the Gabion is a flexible structure that can move. But it is within our limit, so we have observed next 3 years. Now it is 2025, 8 years we have observed. What is the effect on that Gabion? Now it is in
It
the
was
same.
having a very high pressure from the very stage.
Yeah, that's the big-
And one more thing, that those pipes those horizontal, I think pipes, that first the initial stages you
Yes,
installed
yes.
those.
That's
So
it.
those you installed in that settlement area, where the rock to area.
Everywhere. There are doctors in every stages. We have
Ah.
installed the flexible pipe everywhere to release the pressure.
Okay.
And whatever the gap, actually why the Gabion has moved, that is the one reason I am giving. We have done in segment wise. If we have not constructed in one go, sir, we have done half 10 meter, then another 10 meter. So by the time the first 10 meter was constructed, that has moved little bit. The next 10 meter was there. So the construction activity was 3 months, and we have constructed in 15 10 meter stretches. So that is why that movement has happened.
Okay. Okay.
But that water pressure was so high that it moved the Gabion wall, because Gabion wall is a very heavy structure.
Gabion, that you have see the substitution around 800 mm substitution in that zone. I have kept the water bottle there, na? That
Yes, 600 to 700 mm.
Vertical displacement of
Vertical
Gabion
and
wall is
horizontal.
No, not Gabion wall. The first, the initial that area, it was settled.
Okay.
सर डॉक्टर के बैक साइड पे आप रिलीफ वेल भी तो कंसीडर कर सकते थे.
Relief will there, that relief well, sir, we have given us that flexible pipes. But you cannot excavate the entire material to relief, put the finger in, sir, because if you excavate the entire material, we are observing lot of water is coming. If you cannot control at site, when we are working at site, you cannot control the site. So that is why whatever the calculated risk we have taken, and that is why we cannot put entire, we cannot also replace the entire rock toe. We have replaced the rock toe segment wise. So wherever there is a danger we have observed during the construction, we have left it as it is. If you release that rock toe, then entire mass will move. So that is why we cannot do that. Theoretically it is okay that we can do it, we can replace it, but practically there is no scope to remove that one. So I don't know how it is behaving now also. And after 8 years it is behaving good, that is the confidence I am having, but what is going inside I don't know.
Are there any more displacement? More?
No, the displacement is within 500 mm at the beginning.
At the beginning, that's
Thereafter no such displacement.
How you have designed
That-
Gabion wall?
Gabion wall is a
Gabion walls are not meant to take load. What I
Yes,
understand.
Gabion wall is
So have you provided some geogrid? Yeah.
No. Gabion wall is a small 3 meter height Gabion wall. That is not reinforced soil backfill. Only the
Okay, only just support structure.
support structure. It is working as a rock toe itself.
rock to itself.
Gabion
What are the
wall
main precautions you have to take for bulging of Gabion?
precaution. You can put additional support. The backfilling should be with reinforced backfilling. That can be done. Or Gabion box can be done with additional support at the front also. But we have not given that one.
Can you
And
put
How you
additional
have you taken pore water plus the
There is no data with me, only observational
Only two
and
photographs from the security guard.
so I will not explain how they have the design is only simplified limit equilibrium method. But what are the observation we have corrected? That is that sentence I have given, sir. We have convinced this client with these two approach. What I observe, what the performance is giving. So that is the main topic I have highlighted here. In Indian condition, design is the okay, but construction and observation, that is more important. Now in next projects or in future projects I will emphasize on how to design it.
But for 8 years it is working now.
Yes, it is working now.
Okay, your design
So maybe I'm lucky that time. That is what
working.
Anybody else?
What is the time span you observed?
Sir, first 3 months during the construction, then another 3 years.
And
After 3 years,
throughout the years.
throughout the years. That frequency will increase. Earlier daily basis, after 3 months weekly basis. Now they are quarterly basis. They are
Initial season was monsoon season or?
no 3 months. January, February month. So we started the construction. By the month of June we have completed everything.
And the failure happened during the monsoon or?
No, before the monsoon. That साल वैसे कि ना in Odisha will find
So that is some
rainfall is there.
rainfall was there.
उसमें एक्चुअली क्या था?
Thank you, it's a very nice
इतना
presentation.
ज़्यादा है, उसने उसको डिस्प्लेस किया अच्छे से।
So, thank you. So here, that's why I thought we have read lots of theory, and here is through observation. Actually, that was the real dam designer fake. He was approach was observation. Theory, there is called observational theory. So immediately he was doing everything design, now he is no more. He expired at the end of 96 with wheelchair also he is visiting the dams. So like that way his theory was different from the theory. So he was talking about like observation theory. Just try to see and then design instead of following directly the books. So this why I told you like is right because some of the things because being a designer he just apprehended that two things I'll tell you. Morning Sahu was talking about the stress strain curve. So what is the advantage that stress strain curve is residual? Everything safe like unlike a concrete structure we are getting some time in earth structure. Concrete structure collapse immediately in matter of time or second or minute or hour. But in earth structure you are getting sufficient warning. If still we are ignoring only, we are feeling these consequences. So that is the one learning. So that means it is giving sufficient warning. Those who are operations they can identify. And in fact yesterday what I was talking about during visit, the gas deck and all these things, this information what has been provided, it is the 3 months if you are really evaluating it, so you are able to know. Another things I like you are talking about the earth pressure, water pressure. Water pressure like if you see last 3 days, it is the only water which is creating all difficulties. And without any bias and here I say, so Casa Grande might have all of you have heard about it. So he has said one sentence, water is like a beautiful lady, if you can manage, she will be nice, otherwise it will be devastating. So that way that is water. So since last, so water is very important. Whatever you do, unless you manage it, it will create the problem. What he did, simply he relieved the water. And overall if you see, he simply relieved the water. And what is the, yesterday's also what I was telling, that if the flow is simply moving up, so the effective stress is increased, then comes the strength. Strength is not only this when that is water is passing, it is not only taking out something, it is also reducing the strength. So for which we are all designing. So that is reducing. When you say that somewhere it is coming up, so obviously that means already that if you go put anything there, it will go down. So that way this water management, management of water, like you were talking about water resource management practice, yesterday what you were talking about. Even still water, if you can store it with a dike for future use, that is also water balance in TSF. But here you are talking about not TSF, closure. So closure you don't have anything again to store it around. But in TSF also, that water which is coming out from this through seepage or through overflow, that also you can store with another. That is called water. Water balancing now has also become very important. Being in a plant particularly, the water is a big issue. So that part is also we need to learn. So here it is a short 3, 4, 5 days, what only we can ignite or insight say that yes, you have heard about some of the term, if required, you will be able to do it. Or some of the terms what you have seen it here, in your operation or your management, you can put that into that if this may be. I apprehend because he is also like Subhranshu is very, I know him as a student, MTech student. He is very, whenever there is a problem, yesterday you will see that Dr. Parthavish was talking about, do we really need that much of accuracy? He was showing that Japanese flag. One was very red and how much accuracy we need. So he is very good in that solving a problem without looking for very much accuracy. Because that is more important. Do we really need that much of accuracy? That much of camera with this much of pixels? So whatever is solved, if you would have taken that design for 2 years, that time why it would have been written collapsed. If I would have go for design and take the steps by that time, it would have been collapsed. So all these things also, that way he is good in another experience also. He is doing this sol nailing. Somebody designer came after 4 days and say, what is the design method you have followed and so on. Already that time he saved it. Now only you have to prove it that how it is done. So his approach is very much his observation. That's why I say, like when you are at your site, you may not be knowing in theory, but if you really observe, then also you can, something will come to your mind. And that's why engineer, anybody solves a problem is an engineer. Engineer is not a degree. Engineer is anybody who solves a problem is an engineer. That is what we call it as engineer. So that way he always try to solve problem. Thank you, Subhranshu. Now, yes, I request a memento for Subhranshu.
पीछे से लोएगा सर इधर से चलिए